Last part of chapter 9. This is kind of this good one to go through because it does two things for us. It allows us to review the trait stuff and then just add one more little trick, and that's it. Okay, so I want to start off with, let's do a little review problem. Let's go back. There were a lot of questions on this one. I understand why. A lot of questions on this one in the lab the other day. Talking about, how do we solve something like this? If there's an algebra situation at the end, people had it was a little perplexing to them. So let's go through this. Now, if we're gonna set up, if we want to solve for x here, I got to set up a SOHCAHTOA relationship that allows me to have a proportion I can solve for x, right? So the SOHCAHTOA relationships, let's quickly review what those things mean. Now, I want everybody's attention. Drew, one warning. That's it. That's the class's warning right there. Put it down. Okay, so we got sine, cosine, and tangent. Remember what these things mean. Sine of any angle is the ratio of the opposite side length over hypotenuse. Cosine is the ratio of adjacent over hypotenuse, and tangent is the ratio of opposite over adjacent. So we got to do that. When we're setting up SOHCAHTOA relationships from the perspective of an angle, right? And it can't be the right angle. It has to be one of the other two acute angles. So in this case, we'll use this 25-degree angle. We want to label the triangle from the perspective of that angle. So think of a smart talking ant that crawls down in that corner and is looking out at the triangle. How would that ant place the labels 0, H, and A in that triangle? And those are the ones we're going to use. Okay? That's fine. That's fine. You're fine. So how would he do that? How would this ant, which side would he label as being hypotenuse, obviously? The X. X. Okay? Which side would he label as being adjacent? Somebody let's see your hands. Actually, we're not even going to do hands. I've got my cards all ready to go.
Sweet.
This is, oh, I'm so excited to use these things. Great.
Is this the person you were already using? What's up, sir? You look at some nasty.
Okay, so here we go. Shuffle them once.
Hey, shuffle. Hey, you should let someone else cut the deck.
Would you let somebody cut the deck?
I think that,
Okay, here, cut the deck for him.
no.
I'll cut the neck.
Hey, really?
Excellent.
Are you cheating too?
Has a name on it. Has a name on it. So get ready, and you can't, if I pull your card, here's the deal, this is our new game. You can't opt out. If I pull the card, if you don't answer this one, you get the first one for the next question. You get the next one. So you got it.
See you guys later.
Okay, so,
Oh, my God.
no, that's right. Thank you for demonstrating what you can't do. Okay, so we already said that this is H. Now I want to know which one is going to be adjacent, and this one's going out to Devin. What do you think? Which side is that ant? Where is he going to put the A in this triangle? Here's the ant down here at the 25-degree angle. 10. Good. That's adjacent. Good. Okay, and then so last but not least, let's see. Okay, let's see here. No. Connor. Where's the O go? Where's Connor sit? I saw Connor walk in. Oh, there's Connor. I saw you walk in. Yeah. So where's the O go? You kind of walked in the middle of this. Remember, when we're setting up SOHCAHTOA relationships, from the perspective of the angle, acute angle, we got to label the sides opposite, hypotenuse, and adjacent. So that was the hypotenuse, that was the adjacent. Which one must be the opposite side? Yeah, clear over here. The one that he's looking clear across the triangle at. Very good. Okay. So now a little more difficult question. A little more difficult question here. So I want to know, I'll take a volunteer on this one if there is one. Somebody hasn't answered yet. Oh, there's Casey back there. I didn't see you back there. Casey, okay, you take this one. What's the SOHCAHTOA relationship that we're going to use here, and why? Say it again. Cosine. Yeah, good. We want to use cosine. Very good. And what's the reason for using cosine? because I need to find the hypotenuse and I know the adjacent side, right? So these are the two that I want to use because I know this one and I'm trying to find that one. So I want to find the one that uses A and H, right? So it's cosine. All right, so then how could I set up this cosine equation here? Let's see. How about, I'll take a volunteer on this one, if there is one. Hunter, well, how am I going to set up my SOHCAHTOA equation here? Equals, okay, so cosine of 25 degrees, good, equals 10, which is the adjacent divided by, right, that's adjacent, divided by hypotenuse, which is x. Okay, but now, here's where people ran into trouble. A lot of people were successful with that, but then they weren't sure what to do. How are we going to solve this for x? Suggestions? Yeah. Multiply both sides by 10? Okay, I know what you're thinking. That's because we got to get that x by itself, right? Okay, but the problem is, if the x were on top and the 10 were on the bottom, we could multiply by 10. But when I want to get the x by itself, the goal is I have to get the x on top by itself. Okay, and maybe this helps. See if this one thing helps. If I draw 1 under the left side, it looks just like a proportion. Okay, so somebody new here. What could I do? How do I solve proportions? Yes, sir. Say it again. Not quite. Not quite. Close. Danielle. Cross multiply, right? How did we always solve proportions back in chapter 8? We cross multiplied, right? Okay, so if I do that, now watch what happens if I cross multiply. That cross product, if I cross multiply, is just cosine 25 degrees times x, right? So x times cosine 25 degrees. That cross product is what? 10. Okay, and here's the thing you got to get in your head that people still are resisting because it looks so weird. What is the cosine of 25 degrees? It's just a, yeah, it's exactly. Think of it as some weird decimal. It's just a number. It's a calculator number, but it's just a number. Just like pi is a number, right? Pi stands for an infinite decimal number, but we just write it as pi. So what's the last step? Nicholas, what do I do? The last step to get the x by itself?
I forgot, sorry.
Okay, nobody else? Oh, I guess it's somebody new, or I'm going to the cards. Andrea, what do we do? Now, if I want to get the x by itself, think about this. What am I going to do? What's being done to the x? Andrea, yeah. What do you think? Okay, you can pass on this one, that's all right. Somebody want to help her out? Ah, we're on to something. Go ahead, Casey. Which is just a number. Exactly. If I divide both sides through by the number cosine 25 degrees, and look what happens. That number cancels, right? Think what I'm doing. How do I undo multiplying by the number cosine 25? I divide by the number cosine 25, right? And so I get the x all by itself. X just equals 10 divided by cosine 25, right? How do I do that on a calculator? Easy. Especially if it's a graphing calculator. All I have to do is just say 10 divided by, and then there's my cosine button, right? I got to make sure it's in degrees mode, right? If you're not sure how to do that, you can get to the lab, ask me. Okay, I'll take that.
No.
I'll take it.
Put it in a pocket. I'll get it.
Yeah, we're not see it. Next time I see it, it's gone to Mr. Bixler. Seriously, hold me to that. Next time I see that phone, it's going to Mr. Bixler. I'm going to send somebody down with it, and it's gone. Grab your stuff. Grab your stuff in the hall. Okay, so cosine 25. Divide. That's what I get.
That's what
Just
I
a
had.
decimal number, right? Okay? All right. So there's an easier way to do that one. How else could I do that? cross multiplying will work, but you might remember back in A2, there's a little property of proportions that we went through. And I told you that, some of those were a little bit arcane. They weren't that useful, but there's one of them that's very, very useful. So let's go back to this proportion again. Whoops, a little too far, a little too far. Let me get back here. So that's where we were. Okay, got a proportion. How could I accomplish my goal of getting x by itself in the top, right? On the top side. I can't be in the bottom of the fraction. It has to be on the top, on one side of the equation, all by itself. That's what algebra's for, right? That's my goal. When I want to isolate x, I want to get something like this. X equals some stuff that I can calculate, right? Suggestions. This is kind of tricky. Nicholas?
You switch the cosine 25 degrees by x.
Ah, okay, good. Remember, we had a property. Hunter, you have a phone back there, do you? Do you have a phone? Where are you doing, Matt?
Yeah, I was on Moodle.
Okay, I don't want to see it. I'll let you off this time because you're on Moodle, but don't be on Moodle. I want you up here. I don't want anybody on Moodle or anything on the phone, so you're up here. Okay, so we have that's it. This is a good trick. Remember, we had a property of proportions that said we can exchange diagonally in a proportion, right? So I could move the x up to there and the cosine 25 down to there. They could trade places, right? And then I end up with x over 1, which is what?
1x.
What's anything divided by 1? It just itself, right? So x divided by 1, that's just plain old x. And that equals 10 over my cosine 25 degrees in one quick step. That's a good one. I could cross multiply, but it's just more work. I can always do this also, right? Okay, so let's see. Okay, so that's something we can do. Now, what about something like, let's see, I'm going to go back a little bit, or go forward a little bit. Here's one that we already know. Okay, here's one we already know how to do in 9.6. In 9.6, what this section is called is solving right triangles. What does that mean? Solving a right triangle just means I'm going to be given some limited information. I'm going to be given probably 3 pieces of information about that triangle, and I want to be able to fill in, given those 3 pieces of information, I want to fill in the remaining 3. So I have all 6 pieces of information for the triangle filled in. What do I mean by probably 6 pieces of information about a triangle? What do you think? Yeah, 3 sides, 3 angles, right? In this case, they gave me one side, and let's see, they gave me one side and 2 angles, right? I'm supposed to fill in the rest, okay? If I'm given 2 angles of a triangle, I'm really almost given 3, aren't I? The other one's almost free. How do I find the third angle? Somebody different here. Who has an answer? Go ahead, yeah. Perfect, okay, perfect. We know all the interior angles have to add up to 180, right? And so if I just subtract these 2 from 180, that gives me my answer. And I could even maybe take a little shortcut there. I know that being as this one is always 90, maybe you're going to say this, what do these 2 angles always have to add up to, the 2 acute ones? 90, sure, right, because that one's already 90 degrees of the 180, right? So 90 minus 25 gives us what?
65.
65 degrees, there you go, okay? So there we go, good, angles are done. Now we got to get the sides. Well, that's what we just did, isn't it? Right, if I won't even maybe go through this whole thing because we just did it, so let's talk about how we could. If I want to solve for h, let's call that x, how about for now, right? If I want to solve for x, how could I set up a SOHCAHTOA relationship with the 25 degrees? Which one am I going to use? Let's write, and this helps. Write down, until you get this down, just write SOHCAHTOA immediately on the top of your paper or your test when we get there. And that really helps. So from the perspective of, say, that 25-degree angle, how would I label the sides? What label would I give to this side?
O.
O. How about this one?
A.
How about this one?
H.
And so I want to use the sides that I know and am trying to find, right? So why don't I use the 13 and the x? So what trig relationship is that going to be?
So,
Everybody see that? It could be sine, because I'm using the O and the H. So I just say sine 25 degrees equals opposite over adjacent. So that's going to be x. I mean opposite over hypotenuse, I'm sorry. X over 13. And what's the one thing I have to do to solve for x there to get it by itself on the top?
multiply by 13.
Yeah. Now everybody sees that? All I'm doing, because I want to get the x by itself, it's currently being divided by 13. How do I undo dividing by 13?
You multiply it.
I multiply by 13, both sides. And the 13s cancel, and I got it, right? And then if I wanted to find, now that I know what x is, I could put that in my calculator and find a number. I got a couple ways that I could find g. Right, what are they?
Toa and Ka.
Okay, I could use another SOHCAHTOA relationship. Or I could even use Pythagorean theorem, right? Because now I know that side, I know that side. I could use, does that make sense? Probably, I would recommend you don't though. It's easier, honestly, to use a SOHCAHTOA relationship because you don't have to worry about the rounding part. You just round your answer. So I would recommend probably, how about using cosine? Because that would involve 13, and what if we call this one y, solve for y? Wouldn't that work? If I said cosine of 25 equals the ratio of adjacent, which is y, divided by hypotenuse, which is 13, I can just multiply both by 13 again, right?
And they get the same answer as the sine.
I get the same, right, essentially the same answer except cosine instead of sine, right? Is everybody okay with that? Okay, so that one's one you've already been working on. That's probably could have assigned in 9.5. But this one is not. There's one here that's a little different. This one we're stuck with doing something new that I haven't showed you yet. I'm going to show you right now. Okay, so yeah, what about, actually I think I have this one up here, right here. Okay, what about this guy? If I want to solve this right triangle, I've got, this time it's different, I've got two sides and only one angle, the right angle, that's it. So how could I find the length of side C?
Pythagorean theorem.
Everybody agree, Pythagorean theorem? Okay. So if I want to find C, I could just say, I know that a squared plus b squared equals c squared. C is the hypotenuse, so c squared would equal 2 squared plus 3 squared. What's 2 squared?
4,
What's 3 squared?
9.
So, okay, so now here I got another question for you. So if c squared equals 13, I want to know here, let's see, right here. Lexi, here's my question. What would I do to solve for c there? It's a little tricky. What would you do? So I want, c squared is 13. I want to know what c is. What would I have to do to undo squaring the c? Square root, yeah. Does that make sense? Because think about that. That's how we want to do the opposite thing. It actually is the inverse thing in math. If I want to get the c by itself, whatever's being done to it, I have to be able to undo, right? And we've already done some stuff like that. We said, for example, earlier, I think we multiplied both sides by 3 to undo dividing by 3 or something like that. Here's another simple example. What if I want to solve for x? What do I do to get the x by itself?
Minus 4.
I subtract 4, and the reason I'm doing that is because how do I undo adding 4? If 4 is being added to x, I undo it by subtracting 4, right? Agreed? Now, why am I harping on this so much? It seems pretty simple, probably. Why? You'll see. You'll see. I want to get you used to that idea that we're undoing what's being done to the variable to get it by itself. So we're going to come back to that concept here in just a second. Yes?
Could you just come back to where they all
Yeah, you could. You're right. You could. So I get c equals square root of 13, so I can fill that guy in. Okay, but here's where I've got some troubles. Now, what if I want to solve for angle B down here? How am I gonna do that? If I set up, probably you're thinking trig ratio, right? Set up
Yeah.
SOHCAHTOA thing. Now, if I'm gonna set up a SOHCAHTOA ratio here, what do you think? Does anybody wanna make a suggestion? And there's no really 100% right or 100% wrong answer here. But, let's see. What would you do? If you wanna set up a SOHCAHTOA relationship for B, which of those two numbers would you really, or which two of those three numbers would you rather use probably?
Three and on there.
Okay, my options are 2, 3, and the square root of 13. Which one's probably easy to work with? It's such a judgment call, but
I work with those two then.
yeah, you'd work with the top two, wouldn't you? 2 and the 3? Okay, so we want to set up a SOHCAHTOA relationship with these two numbers, just so we can use simpler numbers. So from the perspective of angle B, what are we going to label that? Say it again. Oh, okay, opposite. Okay. How about this one? What's this one going to be? This is an easy one.
Hypotenuse.
That's age. So what's that one going to be?
Adjacent.
Adjacent. Does that make sense?
Yeah.
Okay. So then which SOHCAHTOA relationship do you remember? Yeah, if I write it down again. Which one is going to involve those two? Go ahead. Yeah. So that means T stands for
Unity Burcham, come to the office, please. Unity Burcham, come to the office.
tangent of B, right?
Yeah.
This is kind of weird. Tangent of B, which we don't know, equals the ratio of. Kyle, you out there? Oh, Kyle. Oh, there's Kyle, back there. Kyle, it's up to you. Tangent of B equals the ratio of what over what then? Tangent equals what over what? Opposite over adjacent. So what's that going to be in our triangle for angle B? Okay, I'll come back. Next question. Let's see. Where's Judith? You out there? Oh, there's Judith. What do you think, Judith? What would you say about that? 2 over 3. Sure. Opposite over adjacent, right? 2 over 3. Okay. Yes, ma'am. Yes, you may. Okay, now here's the question though. How in the world am I going to solve this equation? Look what I got here. I've got tangent of B equals 2 over 3, and my goal is to solve for B. How am I going to unlock the B from inside a tangent? And the answer is, this is a rhetorical question for you at the moment because you don't know, but I'm going to tell you. Here's how you do it. There is a tricky function called an inverse tangent whose job is to do just that. There's one for all of our SOHCAHTOA relationships, sine, cosine, and tangent. For sine, it's inverse sine. For cosine, it's inverse cosine. For tangent, it's inverse tangent. Here's what it looks like. So if I take the inverse tangent of both sides, here's the job of inverse tangent. The job of inverse tangent is to cancel out a tangent. So what that leaves me with on the left side is just a plain old B. Okay, is everybody getting that? Okay.
How do you enter that?
Okay, so how do you enter that? I'll show you. So the answer is B equals whatever the inverse tangent of 2/3 is, right? And so the inverse tangent of 2/3, I do this way. If I go to my trusty calculator here, notice that if you look closely, behind the sine, cosine, and tangent, there are these, it looks like sine to the -1, cosine to the -1, tangent to the -1. That's not what it means. Those are the symbols for the inverse functions. So if I hit the second button first and then hit tangent, look what it does. It gives me the inverse tangent of whatever I choose to put in there. So I'm going to put in a 2/3 and hit enter, and it tells me that the angle, that angle B, is 33, if I round it 2 places, 33.69 degrees. Okay? So I can go up here now in my triangle. I can fill that in. Isn't that nice? So I know angle B is 33.69 degrees. So how could I find angle A?
You added and subtracted from.
Yeah. Right, they all have to add up to 180, so I could just subtract, couldn't I? Right? Does that make sense? We got it. That's it.
Yeah,
That's our new trick. So now we can always fill in all 6 parts of any triangle given some information. Okay, make sense? All right, to the lab. 205. Good job today. 205.